We are going to see about in this video the stress analysis of rectangular L bracket. To conduct the stress analysis of L section rectangular bracket, we are using the ANSYS software. It comprises of three steps: pre-processor and post-processor, and its third one processor. Using the ANSYS, we are first launching the ANSYS software using a mechanical APDL product launcher and set the working directory and everything, and using the in the preference select the structural H method as your preference, and preprocessor. In the preprocessor you are selecting the element type. Select that element solid 8 node 82 with the plane stress with thickness as your options, and select the material properties, structural, linear, elastic, and isotropic. So the modeling is being created with the basic primitives, key points, lines, and areas is being added generated using the Boolean operation. So the next step, sixth step is after creating that ideas, after creating the areas, meshing has to be performed. So using the mesh tool, select the triangular and quadrilateral mesh with the element edge length of 2, 3 or 4 or 5. So go for the free meshing. Then after creation of that element mesh, go for the solution processor. In that solution processor, we are applying the load with the structural displacement and solve the current load step. So using the post processing, we are viewing the result. For example, for the von Mises stress, and you can see the animation of a rectangular L bracket. The drawing here is a rectangular L bracket with 150 mm and 100 mm, and with the circular hole of 25 mm and 50 mm on both sides, and with the thickness of 10 mm. And the Young's modulus is 200 gigapascal and Poisson ratio 0.3. And one end of the circle is fixed and the other end we are applying the load. So with this now in detail we will be seeing in the answers. So this is the answer screen. So now select the from the main menu, go for the preference. In this preference, go for the structural option and apply OK. For the preprocessor, in that preprocessor element type, add, edit, delete, and give that add option. In that add, select the solid quadrilateral 8 node 183. OK, and now select the options. In these options, you have to select the plane stress with the thickness. For the real constant, in that real constant, add and give OK and give the thickness value as 10 mm or 5.5. So it depends upon our problem. The material properties can be imported from material library or it can be keying in also. So while keying in, you have to select the structural, linear, elastic, isotropic with Young's modulus and Poisson ratio. After importing that material property, go for the modeling. That modeling, create rectangles by areas with the arbitrary or rectangle by two corners. Now you can see one rectangle is being created. So for the second rectangle, now it's a two areas is being created, and these two areas has to be combined together. So you go for the immediate operation, Boolean operation, add the two areas. So now it is been combined together, and you can see that entity is only one entity. In this two corners we have to need a circle. So for that circle, select that either you can give the center point from the key in, or you can select using the mouse also. You can go to the screen and select that one also. So one side circle is been created, the other circle radius of 25 mm. Now the one rectangle and three areas are there. So all these things has to be combined together. At all that areas, everything is being combined together. So you can see now one single area entity is being only generated. So basic primitives, with the basic primitives we have now created the rectangular L bracket. So in this now we have to, this rectangular bracket has to be fixed, and we have to apply the load also on one end. So for that we need two circles on top of that one, and bottom of the two circles has to be generated. So then now we are selecting in the solid circular area. You can see here one circle is being created. So another circle is also being created. Now using that operation button, subtract areas. So this is the base area. From this one. Areas. Now you can see the, after refreshing you can see that areas is being created and entity will be modified. Now you can see the new modeled finite, just an area has been created. Using an boolean operation only we completed all this task. Now since we are not need of the sharp edges at these corners, we can create a fillet. So fillet is being added. So after completing of all these tasks, we have to create a mesh for our analysis of our. After creating the fillet also we have to do that, make that entity with the main entity. So we are using that operation button, we are adding that area also. So after creation of all the single entity, you are going for the meshing. In that meshing we are already, as per our need, the meshing we are selecting the element length. So depending upon our convenience we can select the element edge length. For the entire area we are fixing it the same element edge length, so that we can have an uniformity of mesh. So the mesh density is also will be common throughout our rectangular L bracket. The completion of that meshing, we have to now apply the loads. In this analysis type is a static structural analysis, and define the loads. After clicking the definition of the loads, so we have to give the constraints and also the where we want to apply the loads. The constraint, the fixation is on all two sides of our rectangular L bracket. We are fixing it with the all degrees of freedom, and we are applying the pressure on the two rectangular L bracket with values of the magnitude value of our load as 10,000 Newton. You can see the application of the load. On the two circles it has been applied, and on the two edges we have fixed. So after application of the loads, go for the solution. In that solution, go for the solve current load step. LS means a load step. Once a solution is being given, you can see the dialog box opened. So you can review our summary of our results. So the solution is done now. Hope you all completed this rectangular L bracket. So now you can view the result using our post processor, and you can change your parameters of viewing the results, either one miss stress or x component of stress or xy or principal stress. Depending upon our need requirement, you can view the results. And you can also view the animation of our results. Animation picture now you can see. So hope you all completed this task of completion of our stress analysis of rectangular L section bracket. So in the next video we will be seeing the next tutorial of our component. Thank you all.